All right, good evening, ladies and gentlemen. My name is Ondřej, and a couple of years ago, I've been diagnosed with a pretty serious and rare condition inflicting my mind. My diagnosis says a physicist. It's terminal, so me and especially my surroundings will have to cope with that for my entire life. But no need to panic, it's not contagious, okay? Alright, you might be quite well familiar with the TV concept of physicists. They are often depicted in various movies and TV shows as very crazy, eccentric people doing crazy things. Well, the truth is that if somebody wanted to make a movie or a TV show or even a single episode about me, it would probably end up in an absolute disaster regarding the profitability, because I simply don't do anything audiovisually attractive. On the contrary, most of the time you would probably find me reading books, recycling ideas somebody had decades ago, trying to find links and trying to see the bigger picture. And if I'm successful, then when I grow up, many years from now, certainly, I'm gonna come up with such a great idea of my own, which will then be recycled by somebody else, maybe 100 years in the future. It sounds very perspective, I know, it's not depressing at all. This hobby of mine is called the quantum field theory. Do you know some fields? Football field, very nice. I'm more meant like an electromagnetic field or gravitational field, but football field will do. Actually, my most favorite field is the potato field. Because potato field can very neatly bridge the gap between agriculture on one side and physics on the other. How's that possible? Well, imagine you are looking over a potato field from a distance. You see it on a scale of distances of tens of meters, and sooner or later you will realize that it's an extremely boring activity. Okay, I tried for you, you don't have to do that. There are some rocks, plants, hills, dirt, disgusting. Anyway, if this doesn't discourage you and you explore such a field, potato field, on the scale of distances of centimeters, you will find that there are really cool things growing out of the potato field. They are called potatoes. And they look like this, or this. Okay, amazing, right? Please, be my guest, pass it along. They're amazing, like there are no bags of frozen fries growing in a potato field. All right, it's pretty much the same story with a physical field. If you look at the physical field from the distance, that means classically, all you see is that each space-time point is assigned certain value, for example, a number, or God forbid, some vector, or something even more dimensional. But if you explore a physical field on the scale of distances, which are 10 billion times smaller than the potato, you will find that there are also tiny kinds of physical potatoes growing in the physical fields. Now, I don't want you to go home disappointed, like, okay, he only showed us some stupid particles from a potato field, like we've seen these in Carrefour yesterday. All right, that's why I brought something with me. I brought something I call the pocket-sized generator of a quantum field. Now, it sounds really like from a movie, and it works exactly that way. You just push a button, and there's a field coming out. Are you ready for that?
Yeah.
Right, I will have to find it first. All right, it's here. So, wow. Amazing, right? What you see here, this is electromagnetic field, or more precisely, waves in electromagnetic field. And they are classically described as vector of electric intensity going this way and vector of magnetic inductance going this way, and it all travels at a speed of light, which is extremely surprising since this is light. Yes, Life is but a limitless chest of surprises. But if we wanted to describe interaction of such a light with, for example, an atom, we would find out that it doesn't work any way other than the light itself is composed of tiny bits of energy, and these we call quanta. In the special case of electromagnetic fields, they also go by the name of photons. So please enjoy photons. All right, this beauty here, this is the standard model of particle physics. Sexy, isn't she? I know, yeah. Well, in all its splendor, the very basic thing it tells us is that the universe around us is composed of only two types of particles. First of them we call bosons. They grow in the bosonic field, and the others are fermions and grow in the fermionic field. Now, while bosons are pretty good guys, and I like to calculate with them because they act casually and are pretty normal, I would like to say something positive about fermions as well, but they are just tiny little bastards, to be honest. They have many bad features, I mean. Amongst them, for example, they are so anxious about their personal space that you can't place two fermions in one spot. I mean, that's crazy. Like, imagine, the lucky of you here came here tonight with their partners in love, and if it was darker here, maybe you would like to sit in one spot, make up some alternative plan for tonight, better than listening to me, which I would totally understand and approve. But if you were fermions, then no matter how strong the feelings would be, you would simply not be able to get into one spot. This weird behavior of fermions puzzled many great theorists in past decades, until they came up with a theory. They thought, like, okay, if there were more good bosons than evil fermions, then the world would be too beautiful place to be true. On the other hand, if there were more evil fermions than bosons, everything would be even worse than it already is. So they thought, okay, there's got to be some symmetry. They thought, okay, maybe every fermion has their well-behaved counterpart in the bosonic sector, and every boson have their spoiled, evilous alter ego as a fermion. They thought this idea was really super. So they called these alter egos superparticles. All right, so for example, electron, which is fermion, has its super electron, which looks just the same as normal electron, only can behave. Similarly, the mathematics, which is used to describe this, is called super mathematics. I mean, all the mathematics is splendid, but this one is super on top. It's amazing. And if there still would be somebody who is not 100% convinced how super that theory is, they call it supersymmetry. All right, I would like to change your perspective a bit here. To all of us, when we first come into contact with quantum physics, it always seems like it's so counterintuitive that it can't be true. Well, that's because, my friends, we are alibists. People love to lie to themselves. We are surrounded by great theories. It's a relativity on one side regarding the big stuff, the fast stuff, and on the other side, it's quantum physics regarding the tiniest of things. And we were like, okay, we are too big for quanta, so let's just set the Planck constant to 0. Hopefully nobody will notice. Similarly, we are too slow for relativity, so let's just pretend that the speed of light is infinite, and here we are, and we call it classical or Newtonian physics. Well, the nature doesn't care, fortunately. Because when you go to study physics, as I'm sure all of you will, I can see it in your eyes. No, just kidding, I can see your eyes. When you will go to study physics, you will sooner or later come across an example, an exercise to calculate how long an atom would exist should it obey the laws of classical physics. Well, the answer is 10 raised to the power of -9 seconds. That's 0.8 zeros and 1 in the end, in seconds. And if I imagine that one day I would like to get married, build a house, get a dog, then doing it all in 0.000000001 seconds is pretty a strict deadline. So I am infinitely grateful that the quantum physics holds the atoms in my body much longer stable, all right? In this context, it shouldn't surprise us that the quantum particles act the weird ways they do. What should, on the other hand, totally shock us is that if we put like 10 to the 28th of such weird behaving particles together, they start to behave like a chocolate, or beer, or something totally classical from our totally classical world. I would like to conclude this with a quote. But first I have to ask, are your professors or your parents here, kids? No? Then I can probably say it. Are you over 15?
Yes.
Then you will understand it as well. Okay, this quote is by a Nobel Prize winner, Richard Feynman. Richard Feynman once said, "Physics is just like sex. It does have some practical consequences, but that's not the main reason we do it for." Thank you very much.